Today I'm going to go over the sand testing procedure. The reason we do that, we want to see how the aggregate sand and the bridging gravel perform in an EPIC profile. So when we do get a sample, we put it in a bag, we figure out its source, and this is what we're going to test. Testing procedure for aggregate is same, and it's usually the simplest part. When you have bridging gravel, you simply put about 5 centimeters inside a clear glass cup, then add water for another 5 centimeters above the bridging gravel, and then pour the sand through the water so it impinges on the gravel below. That separates the sand particles and it aligns the gravel in the very close. So when you look close, a good bridging effect is you have sand on top, gravel below. There's going to be fingers going down, but that's really not that relevant. You just want a general separation. So for example, this glass is several months old. There is no more travel, even though the water is on top. Now for testing the sand, you need some high-tech tools. One is a plastic cup. The other one is a plastic clear tube. It could be glass. This is a polycarbonate tube. The ones I like to use is a polycarbonate. They use this as to protect the fluorescent lights in commercial buildings that are 2.5 meters long. So it's a tube that doesn't break. It has flexibility. It's not going to do any damage when you do that. So the first step is you take your choking gravel and pour it in a cup to about a 3 centimeters height. It's really not that critical. Then you take a tube of certain lengths, and you can cut them in any length you want. Just squish it in so it stays upright with the gravel around it. Then take a funnel, balance it on top, and pour the sand you're going to test right through the gravel. And fill it up till you're about 3-4 centimeters from the top of the tube. As you may know, a lot of the sand you're testing is going to have a dusting effect and be addressed in other areas. This is the small clay particles that are made in the manufacturing process. Once you have a certain height, you want to take your fingers and tap it to get the air out of the system. And then this is what you call a compression test. With a plunger, push down on the gravel fairly hard, and what you're looking for is no compression. So for example, if I had a clay soil, this would actually compress down another 1-2 inches, and that's an alarm that we probably have clay particles in our product. But if there's no compression for, less than 5 millimeters, it's probably not an issue. So this is your test column. The next thing you want to do, and one of the prerogatives I forget, is you start with a dry sand. So the sand sample, if it comes in wet, you dry it in a pan in the sunlight till it's totally dry before you pour it in, because we're taking other measurements in this test. So in the next process, you take a column of water. In this case, I filled it to 100 milliliters. And I'm going to apply it to the bottom gravel, and the water is going to flow around the bottom of the tube, just like the EPIC conveyance chamber, intersect the sand, and then start the capillary rise. So if you close very early on, it's very fast. It starts shooting up and then it slows down. Then with a stopwatch timer on your cell phone, simply put in the time period for 1 hour. So in 1 hour, can you see that, Tom?
Yeah, we're zoomed in.
Okay. So that says rising. You really have nothing to do. Go watch a movie, let nature do what it's doing. So this is the 1 hour mark. We still have a lot of dry sand to go. This is our 1 hour mark, and 24 hours later is up here. So measuring from the water line to what the 24-hour mark gives me my capillary distance. So the determined field height, to that distance, I add another 10 centimeters, which is the operating water line in the EPIC system. So my profile depth is this plus another, another 10 centimeters up here. So that would be my profile height. And this could vary depending on application. So I will still get moisture on normal operating to this level if I'm seeding an athletic field and I want seeds to germinate. But if I'm planting trees, the profile could be deeper. It's just that the sand above this mark is going to be dry. And this is what you may want. If it's dry, the seeds don't germinate, there is no weed growth, and the root system is still going to be in a capillary zone. Now, when this test is completed, another thing we want to do is, since we added a measured amount, in this case 200 millimeters of water, I want to see what water is actually in the profile. So you drain out the water as best as you can, and it's only going to drain on the choking gravel. The rest of the water is now locked in forever till the plants use it up or evaporates from the top down. So by taking the water I poured and pouring it into your original measuring cup, I have 95. So I subtract 95 from 200 and I have a factor of 105. So in other words, this column of sand, which I can determine what the volume is holding 105 milliliters of water. And from there we can calculate how much water my field per cubic meter, per square foot, it really doesn't matter. So that's the water holding capacity. Now at this point we can start the drainage test. And the drainage test is really more important than the capillary test.